Hi students, welcome to Madras Math Kernel. So today what you are going to learn? You are going to learn chapter 2 polynomials, and particularly you are going to see the concepts and example explanations related to exercise 2.2. So subtopic you are going to learn here is relationship between zeros and coefficients of a polynomial. The same thing you would have studied in the last video, that is for a linear polynomial. So now I am going to consider a quadratic polynomial. So consider p of x is equal to 2x square minus 8x plus 6. So factorization methodology you will be knowing, you would have studied in your lower classes. So I am not explaining factorization here. So minus 8x, they are split it up into minus 6x and minus 2x. So by taking common values from the terms, you will be finally getting from these two terms I am taking 2x out, so I am getting x minus 3. From these two terms I am taking minus 2 out, so inside I will be having x minus 3. So I can take x minus 3 out, and inside I will be getting 2x minus 2, and again from this term I can take 2 out. So the remaining terms are x minus 3 and x minus 1. So from this, when you equate the entire polynomial to 0, you will be getting x as 3 and x as 1, right? And you can call these two as the zeros of the given polynomial, because we are equating the given, we have equated the given polynomial to 0, right? And then some new concept you are going to learn here. So if you observe the pattern, what is the sum of the zeros? Sum of the zeros is just adding these two zeros. 3 plus 1 will get you 4. So what I am going to do with this 4, I am going to rewrite this 4 with the numbers available in your given equation. So what is the numbers in the given equation? 1 is 2, 1 is 8, 1 is 6. 2, 8 and 6. So I have multiplied the numerator and denominator by 2. So I got 8 by 2, and I have added one minus sign also. Why? Because in the given expression, if you note down, you will be having minus 8 here, and here you will be having plus 6, and here it is plus 2. So in order to bring that minus 8 inside, I have multiplied the numerator and denominator by 2, and then I have added a minus inside. Okay. So what happened here? This minus is retained here, and then instead of minus 8 I am writing it as coefficient of x, because what your equation says, it is 2x square minus 8x plus 6 is the given polynomial p of x. Okay. So from this is your minus 8. So instead of minus 8 I am writing it as minus of coefficient of x divided by 2. 2 is nothing but the coefficient of x square. So I have written it as coefficient of x square. So from this you can observe sum of the zeros, literally you can say it is a ratio between minus coefficient of x divided by coefficient of x square. This you can consider it as a formula, right? Second, product of the zeros. So product of the zeros is 3 into 1. 3 is 1 0 and 1 is another 0. If you find out the product, it will be 3. Again we have to make this 3 in terms of the numbers given in the polynomial, right? So 3 is not given. So in order to make it as 6, I am multiplying, dividing by 2. I am multiplying the numerator and denominator of 3. Numerator and denominator of 3 by 2. So 3 into 2 by 2 will get you 6 by 2, right? So 6 is the constant term. If you go and see the equation of the polynomial, then you can say 6 is the constant term and 2 is the coefficient of x square. So again writing down here, so you will get it as a formula, that is product of the zeros should be equal to constant ratio between the constant term and coefficient of x square. So generally what you can say, in order to frame it as a formula, generally the polynomial should be of the form ax square plus bx plus c, and assuming alpha and beta are the roots of the given polynomial p of x, then sum of the zeros is equal to, the two roots we are considering here is alpha and beta. So alpha plus beta is the sum, right? So alpha plus beta should be equal to minus coefficient of x divided by coefficient of x square. There is nothing but minus b by a. So you have to remember this as a formula along with this equation, otherwise you will confuse, right? And product of the zeros is alpha into beta, that is equal to constant term divided by coefficient of x square, that is equal to c by a. Again you have to remember this formula also while working out the problems. So now coming to example 2. So what it says, find the zeros of the quadratic polynomial x square plus 7x plus 10 and verify the relationship between the zeros and coefficients. Okay, so I have considered the polynomial x square plus 7x plus 10. So to help you in the factorization, I have written it here. This should come on the top here and this number should come inside. So you have to take two numbers so that on multiplication it should get you this number. When you add up these two numbers, it should get you 7. Okay, so I am multiplying 5 and 2. If I multiply 5 and 2, I am getting 10. If I add 5 and 2, I am getting 7. Okay, so what I have done it here is, since the sign for these two numbers is plus, I have written it as x plus 2 into x plus 5. And I am equating it to 0. Why? Because in order to find out the zeros for the given polynomial. So I got either x plus 2 should be equal to 0 or x plus 5 should be equal to 0. Therefore, I got the values for x as x is equal to minus 2, x is equal to minus 5. Therefore, the zeros are minus 2 and 5. And in your question, you are asked to verify the relationship between the zeros and coefficients. Okay, so what is the relation? Sum of the zeros formula should be minus b by a and product of the zeros should be c by a. Okay, so sum of the zeros, literally I got the zeros as minus 2 and minus 5. So when I add up, I got minus 7. Okay, so in order to relate this to the considered equation, the equation is, or the given polynomial is x square plus 7x plus 10. So I want to bring this plus 7 into the picture, right? So what I have done is, this is plus 7. Okay, this is plus 7. Already minus is there as per the formula. So minus 7, I have added up 1 here because 1 is having, if I put 1 or if I am not putting 1, then there is no difference in that. So I have added 1 there. So minus 7 by 1, that is equal to minus, I am returning 7 is nothing but the coefficient of x and 1 is the coefficient of x square. Okay, so this is the verification for the sum of the zeros. Similarly, product of the zeros is, you multiply minus 2 and minus 5, you will get 10. 10, it is there in the equation or it is there in the given polynomial. Okay, so I am again putting 1 in the denominator, right? Because putting 1, it won't alter the value of the number. So 10 by 1, if you see, 10 is the constant term and 1 is the coefficient of x square. So with this, your given product and sum are verified. Product and sum of the zeros are verified here. Okay, coming to example 3, find the zeros of the polynomial x square minus 3 and verify the relationship between the zeros and the coefficients. So what is the polynomial here? X square minus 3. Okay, so x square minus 3 is equal to 0. Therefore, x square should be equal to plus 3 and x is equal to plus or minus root 3. Okay, because x can take both the values, plus root 3 also can come, minus root 3 also can come. Therefore, the zeros are plus root 3 and minus root 3. So as per the formula, you have to verify whether these sum of the zeros are equal to the sum of the zeros found out using formula. Okay, so literally sum of the zeros is root 3 minus root 3, that will get you 0. And if you try to put in the form of a formula, it is minus coefficient of x is 0 because the equation is x square minus 3. Coefficient of x is 0 divided by coefficient of x square, it is 1. So 0 by anything is 0. So it is verified. And coming to the product is root 3 and then again multiplied with minus root 3. So I got minus 3 divided by 1. I added up 1 there. Okay. So what is this minus 3 from the equation? It is the constant term. So minus 3 is a constant term divided by coefficient of x square. Okay. Coming to example 4. So coming to example 4, find a quadratic polynomial, the sum and product of whose zeros are minus 3 and 2 respectively. So let ax square plus bx plus c be the quadratic polynomial, and I am assuming alpha and beta are the zeros. So what it is given? Sum is given, sum of the zeros are given, product of the zeros are given. So alpha plus beta is given as minus 3 and then product is alpha and beta is given as 2. So how to find out the equation with these data? So alpha plus beta, it is given as minus 3, alpha beta is given as 2. So what I can do, I can put a 1 in the denominator because it won't alter the value. So when I put 1 here, I can compare this minus 3 by 1 to the regular formula, that is minus b by a. Minus b by a, it is nothing but b is the coefficient of x over there and a is the coefficient of x square. So if I compare with this, then I can have some idea that coefficient of x should be 3, that is b should be 3, and coefficient of x square can be 1. And coming to the product, alpha beta is equal to 2, that is 2 by 1. Okay. So 2, on comparing this with the formula, I concluded that the constant term should be 2, that is c to be 2, c by a. So c should be 2 and a should be 1. So here also I should make a verification whether I am getting both the a's are same, right? So here a is equal to 1, b is equal to 3, c equal to 2. So this should be substituted in the general form of the polynomial, that is ax square plus bx plus c. So what is a? 1, b is 3, substitute there. So 1x square plus 3x plus c is 2. So this is the required equation. Then coming to the point to be noted there, for a cubic polynomial, the general form of a cubic polynomial is ax square plus ax cube plus bx square plus cx plus d with alpha, beta, gamma as their roots. Okay. So here alpha, beta and one more root got added because the degree of the polynomial is 3 here. Okay. So alpha plus beta plus gamma, that is sum of all the 3 roots should be minus b by a, but here your b varies. In the quadratic polynomial, b is the coefficient of x, but here b is the coefficient of x square divided by coefficient of x cube, and then this is one more new sum is added here, that is sum of the roots taken 2 at a time. We used to say like this, that is alpha beta taking only product of the 2 roots at a time and then adding all the 3 will give you some other new term, that is out of 3 roots alpha, beta, gamma taking 2 at a time. At a single instance you have to take 2. Alpha, beta you have to take first time, and then beta, gamma you have to take the second time, and then you have to take alpha, gamma, and then adding up all those 3 will give you a new value c by a. What is c? C is the coefficient of x and a is the coefficient of x cube. All these are with respect to the cubic equation. Okay, then final term is as usual alpha, beta, gamma, that is minus d by a, that is equal to minus constant term divided by coefficient of x cube, right? And then coming to example 5. So what is example 5? Verify that 3 minus 1 minus 1 by 3 are the zeros of the cubic polynomial. P of x is equal to 3x cube minus 5x square minus 11x minus 3, and then verify the relationship between the zeros and the coefficients. Okay, so you are given with the zeros and you have to verify whether they are the zeros for the given polynomial, and then as usual you have to verify the relationship between the zeros and the coefficients. So first, comparing with the general equation ax cube plus bx square plus cx plus d, I have written what is a, what is b, and what is c. Okay, what is c and what is d. So first I have considered the polynomial p of x. So what is p of x? It is 3x cube minus 5x square minus 11x minus 3. So first I substituted the first value, first 0, that is p of 3. So I replaced all x with 3, and after simplification I got 0. Therefore that 3 is found to be the 0 of the given polynomial. In a similar way you can check it up for the remaining zeros. That is second 0 is minus 1 and the third 0 is minus 1 by 3. So after substituting minus 1 I got 0. In a similar way for minus 1 by 3 also I got 0 here, right? Therefore I concluded that 3 minus 1 minus 1 by 3 are the zeros of the given polynomial. Then for regular verification I have taken a is equal to, I have rewritten here a equal to 3, b equal to minus 5, c equal to minus 11, d equal to minus 3 for reference purposes. So here what are the zeros? One is 3, another one is minus 1, and third one is minus 1 by 3. So when I find the sum, it is alpha plus beta plus gamma, that is 3 plus minus 1 plus of minus 1 by 3. So finally I got the value 5 by 3, right? 5 by 3. But in my equation my b is minus 5. So in order to bring that minus 5 into the picture, I have added one more minus here. So in order not to alter the value, I have added one more minus inside. So minus of minus 5 divided by 3, that is equal to minus b by a. So this is verified. And second one, sum of the product of the roots taken 2 at a time, that is alpha beta plus beta gamma plus gamma alpha, that is 3 into minus 1 plus of minus 1 into minus 1 by 3 plus of minus 1 by 3 into 3. So finally I got the value minus 11 by 3. So already minus 11 is there in the picture and 3 is also in the picture. So directly I have written it as c by a. And then coming to the last thing, there is alpha beta gamma, it is equal to 3 into minus 1 into minus 1 by 3, that got me 1. So 1 is not there in the given polynomial. So but what we want here, we want minus d by a. Our d term is minus 3 here. So what I have done, I have multiplied the numerator and denominator by 3, by minus 3, okay, sorry, by 3 only. Then I have added minus sign inside and outside. So minus of minus 3 divided by 3, that is equal to minus d by a.